Week 5 lecture video, and we're still talking about the fundamental counting theorem. And I just finished giving you a simple example using ice cream sundaes. And we found out that if we have different ways of doing something and we want to combine those ways to see what all the possibilities are, it's the number of ways times the number of ways times the number of ways, the fundamental counting theorem. So let's take a look at our next example that's in your notes packet. We're going to Applebee's. We have 5 choices for appetizers, 7 choices for entrees, and 4 choices for desserts. So if I want to figure out all the possibilities, I am certainly not going to write them all out like I did for the ice cream sundaes, because this is going to be a lot of choices. In fact, it's going to be 5 choices for the entrees times 5 for the appetizers times 7 for the entrees times 4 for the dessert. Multiply those 3 numbers and you get 140. The fundamental counting theorem is really easy to use. Alright, let's see how it works for the gymnast problem. We have a pool of 15 gymnasts, okay? So I'm going to put my pool of gymnasts over here. Got 15 of those little buggers jumping around. Okay, and they're competing for gold, silver, and bronze. I'm going to make my podiums. Here's gold, here is silver, and here is bronze. Okay, now any one of the 15 could win gold. So there's 15 ways for gold to be won. Any one of 15 gymnasts. But whoever takes gold cannot take silver and cannot take bronze. They're not allowed to win more than one medal. So that leaves just 14 gymnasts left in the pool of contestants to win silver. So there are 14 ways for the silver medal to be won. Any one of these 14 remaining gymnasts. Now my bronze medal, okay, well these two can't win it. So that leaves 13 possible gymnasts left to win the bronze medal. So if I can, and the gold can be won 15 different ways, the silver 14 different ways, and the bronze 13 different ways, then there are 15 times 14 times 13 possibilities for the ways the medals could be distributed. So we take our calculator and we multiply those two, times 14 times 13, and I end up with 2,730 possible combinations for awarding the gold, silver, and bronze medal. Pretty cool to think about. Going on, how many different 4-letter words can be formed by randomly selecting letters from the alphabet? Well, this time my pool is 26 letters in the alphabet. 26 letters in the alphabet. Now, we're making a 4-letter word, so let's get the spaces ready for our word. Now, this word can be nonsense, by the way. It doesn't have to be a real word. This would take us an infinite amount of time to figure out. So it's just going to be any combination of 4 letters. Now, we're selecting them randomly. That's one thing to know. And the second thing to know is it doesn't say we can't repeat a letter. So, for instance, a word could be M, 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 M. That would count. Alright, so let's look at the first letter. How many choices do we have out of the alphabet for that letter? Well, we've got 26 choices. Now, since it's okay to repeat letters, I didn't reduce my pool at all. There's still 26 letters I can choose from for the next letter in my word. So I've got 26 ways to do the second letter in the word. I have 26 ways to do the third letter, because again, I could repeat the same letter if I needed to, or I could pick a different one from the pool. And I have 26 letters possible for the fourth. And so fundamental counting theory says that if I can do the first letter 26 ways, the second one 26 ways, the third one 26 ways, and the fourth one 26 ways, then all I have to do is multiply those, and I'm certainly not going to enter 26 into my calculator 4 times. I'm going to do 26 to the 4th power. 26 raised to the 4th power is a big number. A lot of different possible combinations for words, which is why there's lots of possibilities for license plates and other forms of identification. 45,000, whoops, get the comma in the right place. 456,976 possible 4-letter words, nonsense or otherwise, can be formed from the alphabet.